We're going over questions on the integration as net change for those of you guys just joining us. If you're on the field trip today, we are all jealous. Okay, so number 6, they gave us a function, and the function was for what? Was it an amount, like an original? Was it for a rate or a rate of a rate? Those are pretty much your 3 options.
Rate of a rate.
Rate of a rate would be like acceleration.
No, it's just
it's an original. Good, just like an amount. An amount of what? Degrees Fahrenheit, right?
Mm-hmm.
So this is a temperature, this is an original, this is like an amount, okay? Temperature inside a house, outside a house, I apologize. There we go. Letter A and B, you guys have already gotten through. So letter C says the cost of cooling the house accumulates, which means adds up, at the rate of 5 cents per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. Now hold on. How are we going to figure out exceeding 78? So if it's like 80 degrees, those are 2 degrees above 78. So those 2 degrees would make a difference as far as the cost. What stands for temperature? What stands for temperature? The function, right? Okay, so F of T are the degrees, are the temperature outside. We're trying to figure out when this temperature exceeds 78 degrees, what math operation would help us as far as exceeding? Subtraction, good. Just, okay, what's the temperature and subtract 78? What we care about are all the degrees that are over or above 78, right? Wait, did you guys already figure out when the temperature goes above 78?
That's B.
Exactly. So hold on, what times did you guys get when it exceeded 78?
5.23 T. I mean, is between.
Okay, well, I'll try to help in a second, but we actually didn't ask on these, so give me one moment. So the answer was 5 point what?
23 to 18.7. Oh, well, yeah, no, she's saying 5.2307.
Okay. But you guys could have rounded to 231, or you could have made it 230, or you could have made it 2307. All of those would be okay as long as you have 3 decimal places after. But what's the next one?
18.7.
So 76 something, right?
9.
Okay, thank you.
And that would be hours, right?
I know, I remember.
Okay. If you guys are wondering how to find this was a calculator FRQ. If you were to graph this and get the window, you would have made the window between 0 and 24. And then you would have had to go up above 78, so maybe, let's just say maybe up to 100 or 110, I don't know. Pretend you're in California. You had some sort of bell curve, if I remember right.
Yes.
And you would have graphed, if I were you would have graphed y equals 78.
And then 5.26.
So this could have been y2, this could have been y1, and then all you have to do is find intersections. Yeah, you didn't have to show any math, to be honest. You could have showed the sketch. But then you get those 2 points.
If you just write intersection points between...
Oh, don't do that. You're stupid. Like, does that make sense? Like you're dumbing it down and they don't need it dumbed down. I don't either. Just give them the intersection points. There are some kids that are like, I found the zeros. I might never explain what you did in your calculator. Just show them the basic core of, hey, okay, you know, these times. Got it done. Okay, letter C says the cost of, so we already know what interval or for what interval the temperature is above 78. So we're not just going blind. So therefore we can go ahead and say, all right, so we need to go ahead between our, we could call this, if you guys want, we could call this A and we could call this B, and that way we could just go ahead and not have to write the decimals and put A to B. Remember your cool little calculator does that little stow thing? You can stow, so you can stow this variable, or this quantity is A, store this variable as B. Because remember, even though you're writing it with decimals here, do you want to put the decimals in here all rounded? No, you want them as extended as possible. So you would stow this one as A, stow that one as B, or just write out the entire thing, or copy the entire thing in your integral by going up in your calculator and stealing it. But hold on, we need all the temperature above 78 degrees, so I'm going to take my F of T. What the temperature is, take away 78, and that will tell me the degrees above 78. That'll get me all these degrees, but not take into account the 78 below. And then you would need to go ahead and the integral will accumulate all the different degrees, all the, it'll accumulate all the temperatures above 78 for all the different times in between those two. not just at set intervals, but for every single infinitesimal length in time. So all I need to do is multiply that by 0.05. Need all those degrees above 78 for the interval where the temperature is above 78 times the 5 cents. And it's per hour. The hours matches up with the hours up there, so we're okay on that. What was the total cost in a cent to cool the house for that? If you guys want to think about the units, it'll confuse some of you, so for some of you just tune out. But this one is 5 cents per hour. And this one, when we integrate temperature, will actually end up with degrees Fahrenheit hours. And so those two cancel, and so we're doing the price per degree Fahrenheit, and that's how it all works. What'd you say?
Dimensional analysis.
Yeah. It can definitely help out sometimes, that's for sure. Okay, that was number 6C. Number 7C was our next one. 7C was the amusement park, people going in and people going out, right? How many people were in the park when it opened?
0.
0 customers. I'm sure there are workers, you guys make an argument for that, but 0 customers or 0, what do you call them? People, amusement people. I don't know. Just people.
Yeah,
Okay.
I don't know.
So our initial people in the park are 0. Okay, besides the workers, and we're not counting them. This is like just the customers coming to do the park. The park opens at 9. That's why the time starts at 9. And question: when does the park close?
At 11, which is 20.
At 11, right? Does that make sense? Because 24 would be midnight. 23 is 11. So it's open from 9 to 11. That's kind of normal. Somewhere between California Adventure and Disneyland. So you guys are on C and D. Letter C, they give us this new little H, but hopefully if you've already been looking at going in and coming out, hopefully you've already thought about, hey, if I subtracted the two, people going in, people leaving, if you subtracted the two, what do you get? The people in the park currently. Does that make sense? People are going in, people are going out, so then if I subtract the two and say, oh, hey, how many people are in the park? That's what H is. How many people are in the park at time T, starting from 9, going to time T, so starting from opening till, you can figure out how many people are in the park. They say H of 17, the nearest whole number is 3725. 17, that's a time, right? T? What time would that be?
17 o'clock.
17 o'clock, which would be 12 plus 5, right? 12 plus 5 is 17, so it would be 5 p.m. So how could you explain this, the value of H of 17? There are 3,725 people in the park at 5 p.m. It says explain, right? Explain to me of H of 17 and H prime of 17 in the context of the park. How could I find H prime? Well, don't you just take a derivative to get a prime?
Yeah.
If I take a derivative of this guy, I also have to take a derivative of who he is, which is this guy. What theorem lets me take a derivative of an integral? Part 2.
I know.
And it's going to end up being, it's a constant to a variable. It's not a u. I don't need a u prime, just plug in. E of 17
I know, I'm missing 2.
minus L of 17. E of 17 minus L of 17. Why? The derivative of an integral, you plug it in and then say times u prime, which is just 1. So it's just t by himself. How do you do this? You plug into your calculator, your calculatrice, your calculadora using that whole y bar thingamabob, right?
Yes.
So I don't need to show any more work. I'm going to my calculator, and those of you that already did it, what'd you get?
Negative 380.281 people per hour.
I think you already had them in like your functions for another problem. So you could have just done like value. That's quicker.
But on a graph, you'd have to actually get the window. I don't know if it'd be worth it. I would just do
No,
the y
like, I
one.
think you had to for another problem though.
Oh, right. So you're just plugging into your calculator, right? Like you already have it already in there.
Yeah,
You're
I
just
think
plugging
you
in
already have the
17.
graph.
So negative 382.81.281. They say explain the meaning. So there are 3,725 people in the park at 5 p.m. And
People are entering and leaving, technically, so it'd just be
From.
leaving.
But it's from 9.
Just
the number
P though.
of people in the park is decreasing at a rate of 380.281 people per hour at that.
What if you just
That's
said
one way.
like
Already.
h prod of the penis, like the rate at which the number of people in the park is changing?
You'd probably be okay. You could say something like, and the rate at which the number of people in the park are changing is negative 380.281. But they do like it when you notice that the negative is decreasing. But just don't ever put decreasing and a negative. Remember, a double negative makes it a positive. That's not sound good. Letter D says, at what time t within 923 does the model predict the number of people is a maximum? Ooh, a maximum.
Oh, wait, that's the one.
But I know max is when the quantity's derivative is a 0, and h prime of t changes from positive to negative at. That's enough to say it's a max. I just need to figure out where it is. Question, guys, could you have taken e minus L and actually graphed it?
Yeah, that was just the way I did it.
You could have taken e minus L and actually graphed it and played around with your window, and then you could have actually found the max. That's one way of doing it. The other way of doing it is that you could have taken h prime, which would have been, oh no, that is h prime. Sorry. Don't find the max of this. You would have found a 0 from this.
Well, because it's at the moment where the rate of decreasing is greater than the rate of increase.
You could have graphed E and L separately, or you could have just graphed E minus L. Trying to go back to, oh, my calculator's not coming up. Okay, as we wait for the calculator to come up, I think he's coming up. Let me go ahead and get something passed out to you guys. Is he coming?
Like, why did this pen stop working? Look, it even was weird. But it just does not go so low. What? No. David, that doesn't work until like the last drop of 8 plus of
They don't work as efficient as they would have.
No, they do, David. They don't work on pressure or gravity pulling down.
Yes, they do.
They don't, David.
How do you know? Is it class? Well, ask your friends.
No, they don't work on gravity pulling it down.
So that's why it looks so bad.
No, these are not.
You're really good. What is that? Is it so?
Wait a second.
Wait, you're gonna be here at lunch,
This
right?
is a slow field of.
Oh, you have a meeting?
Meeting being published for
Alright, so, okay, so
Is this wind? Oh, it is wind. Oh, that's good. Alright.
I'll pop in for a quick laugh real quick.
What news broadcast gave the wind over the news?
Alright, kiddos, right now I'm putting the function in my calculator.
Oh, wonder something.
Hey guys, I know some of you don't need this, but some of you really do, so give me just a second to show on the calculator how to do this.
I don't know how you're doing it. There's a whole notation like
At different points in the problem, you probably would have needed your
calculator.
yeah, well, yeah, your calculator, but you would have needed each of the functions. So at one point, you might have needed your e function, which I'm putting in now. Remember, the x can just represent the t, no big dealio. So at one point, you might have just needed the e. At one point, you might have just needed the l. So it probably would have been a useful thing in order to put them in separately. It probably would have been useful to put both of them in. There we go, 980 all over x squared. However, are there times like when the h comes into play where it might be helpful to think about them together?
Yes.
And the answer is yes. Didn't we just say that, there we go, that h prime is equal to e minus l? And in order to find a relative maximum, we need a critical number, aka h prime to equal 0, and we need h prime to change from positive to negative, so that h changes from increasing to decreasing. You never need to tell the AP guys both. One of them is sufficient. So I'm really just looking at E minus L. So I could have, like Tyler said, I could have looked at them separately and thought about, okay, when E is higher than L versus when L is higher than E, people are leaving is at a faster rate than people are entering. But what might be easier is just to say, wait a minute, we're just talking about them both, so why not just put in, I think it's alpha trace. Can't I just put in E minus L?
Oof.
Okay.
Oh my gosh, that's nice.
See, I can just put in E minus L, and then if I put in E minus L, then I can actually just graph him. Now I know that my window needs to be between 9 to 23. If you guys want a better picture, you could go like 0 to 23. That could work too. I do see some pretty big numbers as far as how many people are in the park. I see the 3725. Let's go up to maybe like 15,000. I don't know, just to be safe.
No, well, because it's decreasing at 3725, so it's probably not that big.
Yeah, I wouldn't think so, right? But just to be safe.
I
Okay.
just want to see where it crosses.
All we care is where it crosses. Right there. See it? So it came from 0 because there were 0 people in the park. In the morning, there weren't that many people coming in. And then it reached its peak as far as the rate of change, But here's where H prime equals 0. So I'm not looking at the maximum of the rates. I'm looking at the maximum number of people,
This is incredible.
which I will find by finding the 0.
Is that the great graph of
Of course, you're gonna
H
have to do it.
This is the graph of E minus L, and E minus L is H prime.
Okay, so if it was just H, you
Yeah.
have
If it was just H, I'd just look for the max. But since it's H prime, I'm looking for the 0 where it goes from above to below. And that 0 where it goes from above to below is right here, 15.794.
Same thing, but when I did it, because they're
Yeah, you're
both
looking
rates,
at the
so you know that the time where it's maximum is when the positive rate, like this, equals the negative, because all before it is been increasing.
Or you just think of our relative max
No,
card.
it's the same thing.
Yeah, but you're saying it differently.
It's the exact same
Yeah,
thing.
exact same answer, right? So that was number 7C. Now let's go peek at number 10C and 11C. Nice, seems like we have more questions on.
But then it stops.
Oh, you got number 9?
Okay.
10C,
Yes.
cars in the intersection, right?
Yes.
This one, they give you a graph and a function, true?
Yes, there is.
Okay. On the graph,
What period is it there?
all right. We have right here a rate of how fast cars per hour. How fast the cars are turning left. Do we really care that this problem is about cars turning left? No, we care about the math. So whatever, here's a rate. How quickly they're turning left. They give us a time interval, 0 to 18, when we're looking at things. And then they give us the graph of L up above, which is the same thing as the function. And letter C says traffic engineers will install a signal, like a light signal, if there is any 2-hour time interval, so that's how wide the interval needs to be, in which or for which the product of the total number of cars turning left and the total number of oncoming cars traveling straight. So hold on. Right now I have number turning left times the number of oncoming. Product. In math, the word product means times. Yeah. Through the intersection is greater than 200,000. Now we're like, okay, well hold on. How do we figure out how to mathematically express these two? At every 2-hour time interval, 500 oncoming cars travel straight through. So I can go ahead and make this 500 right now. I'm just trying to see, can I find a 2-hour time interval where the number of cars turning left times 500 is greater than 200,000? Well, if this is the rate at which the cars are turning left, because right now I could do, I don't know, 0 to 2, or 1 to 3, or 2 to 4, or 3 to 5. I could test all of those, but that would be so much time. I'm just trying to say, is there a time? Well, guys, look at the graph. Isn't the number of cars turning left from the rates graph, isn't that seen by the area under? Why would I not try 0 to 2? It's a very little area. Why try that? It's probably going to fail. I need to think of peak times and test the peak times, right? So where are the peak times? Well, I see one here, and I see one here. Which one looks greater as far as area under?
Right.
Right here.
There's
So
plus
I'm going to go
minus
ahead
one.
and figure out about where that seems to hit, which seems to be at about 14.
Mhm.
And I'm going to say, all right, cool. Let me go ahead and try maybe 13 to 15. If you were to try the interval from 13 to 15, chosen strategically, because we went at a peak time and tried to see whether or not those 2 hours are going to get it. Because if these 2 hours don't get it, well, none of the others will. 13 to 15 of my L of TDT. Guess what happens? It ends up being greater.
Oh.
Meaning, yes. And you can say something to the effect of the rate at which the cars are turning fastest occurs around 14.
That's similar.
So then taking the integral from 13 to 15 of L of TDT times 500 will be greater than 200,000. They have to install a light. Done. They have to install a light. But that's why I chose 13 to 15, because you look and say, hey, where's the area the greatest? Well, here, go to the peak time. Don't test all these other random times. Go to when they're turning the fastest. We have the highest probability of getting the light installed.
Are they usually just 3 parts?
Are you usually just what?
3 parts. Those are the one of
There's
these.
been up to 4. Rarely anything more though. Okay, number 11. Concert tickets. People waiting in line. And we're looking at letter C. And then we're good with all these questions. Okay, we have a table, right? Almost always when you have a table, some existence theorem is going to come into play. EDT if there's a highest or lowest. IVT if there has to be a value at. MVT, does there have to be a rate that's 0 or some other number? Almost always with a table, one of your theorems comes up. Concert tickets went on sale at noon, sold out within 9 hours. They tell us about L, but they don't actually give us a function L. They just give us certain little snippets of time. We don't totally know what's going on in between, because they don't say like it's strictly going up or strictly going down. We just get little baby snippets, little baby peaks. Letter C says, what is the fewest number of times at which L prime must equal 0? Ooh, must. Theorem. There must be a time at which the derivative equals 0. It sounds like rolls, which is a specific case of MVT.
Yeah.
The AP guys would use MVT because it's the general overarching umbrella theorem. So let's look at this real quick. MVT says, well, even Rolls says, if we want to start there, Rolls says the derivative must equal 0 if I have any points at which f of a equals f of b, or L of a equals L of b. Are there any times where these totally match up?
No, like, no.
So Rolls isn't going to work. But the idea of MVT still totally can. Because question, on average, what happened with the number of concert tickets being sold between 0 and 1 on average? Increase. We would do f of b minus f of a all over b minus a. The average rate is an increased rate. On average, what happens between 1 and 3? Increase. On average, what happens between 3 and 4? Ooh. If this is a twice differentiable function, and if it increases and then decreases, maybe not strictly, but an average increase and an average decrease, IVT says what has to happen if you have a positive and then a negative? What has to happen in between? There has to be a 0. There's 1, right here to here. Then decrease, average, and then increase. So negative average to a positive average, what has to happen in between? Another 0. Increase to decrease, another 0. Decrease. Okay. 3 zeros are guaranteed. Now there are multiple different ways of wording this. I don't know exactly how Mr. Calculus does it. I know it's a little bit different than the AP answer key. But what I see is, where did we go? Between 0 to 4, we have 1. 0 to 4, then 3 to 7, we have another. And then between 4 to 8. You could even say 1 to 4. 1 to 4, 3 to 7, 4 to 8. At least, I should say this way. I'll find. must be 0 at least 3 times I'll put at least once. One to 4, 3 to, what was it, 7? You guys have it in front of you. And then 4 to 8? Is that right?
Can't you just say 3 times in the interval 1 to 8?
The problem is you need to actually defend that by the justification. Let's answer. Since IDT guarantees zeros when the average rates change. Does that make sense?
Are you good?
No, because I need to show the increase, decrease, decrease, increase. I need to show the whole thing. Because the whole point is that IVT says, hey, if the average rate is positive and then negative, or negative and then positive, so I have to show both ends. I have to show the negative average rate and the positive. The average decrease, the average increase, I need to show all of that.
What
Does
does
that make sense?
IVT state?
IVT states, for a continuous function f of c must equal k for some c within a to b and k within f of a to f of b for some value. That's a little bit messy, but the long story short is for a continuous function to go from one y value to another y value, it must hit all the in between. So up there, for our average to be positive and then negative, it must hit everything between the positives and the negatives, it'll hit 0. To go from a negative to a positive, it'll have to hit everything in between, it'll have to hit 0. Does that make sense? Okay. Okay, those who've gone ahead and finished our questions that you guys explicitly had, doesn't mean that someone doesn't have another individual question. Long story short, remember, when you turn it in by the end of the day, I need to see it fully attempted, number 1. I need to see it graded, number 2. And then we'll be good to go. So you guys go ahead, and if you have it ready, you can just pass it back, pass it over. Maybe Sean can collect it and put it back in the tray. If somebody still needs to hold on to it by the end of the day, remember you can turn it in by school to my phone or after school. So I want you guys to go ahead and open up for just a couple minutes
Just one.
our slope field notes.
2 to 3. All right, David. Do you think you could put the slopes? You know, I have them in the field. Do you have to move them all out? Sorry, it's okay, David.
I appreciate that.
I'm just wondering, because it would really be arduous to move all of those otherwise.
I ran it around. That's like the worst shirt like.
That's pretty impressive, actually. Is that?
Wait, so what do we?
All right, kiddos, let me make you a deal, okay? I want you guys to go ahead and work through with me, if we can do it, 2 problems, I think. You're not going to take any notes. Instead, what I want you to do is tonight get your notes all the way updated until the last example that we're going to cover, okay? So just go ahead and pay attention. If you want to write this down, you can, but just go ahead and pay attention. I'm going to do it kind of quickly. I want you guys to at least have an introduction and have your notes all the way up tonight, updated through the last example that we do. Sound good? Okay. This is what we call a differential equation because it has a derivative in it. Long story short, it's technically called a first order because it's a first prime. It's just a single prime, not a double or a triple prime. If we want to verify that something's a solution, we can go ahead and take the prime of it, which would be 3cx squared. Then we plug in. So x times y prime would be x times this guy, 3cx squared, minus 3 times y would be this guy, cx cubed equals 0. That's our question, that's what we're trying to verify. If you guys notice, that'd be 3cx cubed minus 3cx cubed, 0 does equal 0, and we're good, right? What does it mean when it says find the particular solution, and then it gives us this little clue?
Plug in.
Plug it in, plug it in. So then we can go ahead and say, oh, all right. Well, if this works, then therefore let me go ahead and plug in y equals cx cubed such that we have the point negative 3, 2. So we could plug in 2 equals. This is introducing you guys to the idea that c eventually will not always end up in a plus c spot after simplifying. This one I would get negative 2 over 27, which would lead me to the particular solution of y equals negative 2 27x cubed. Okay, that was just something to do with differential equations and kind of just introducing the idea, which I did on Thursday. What we haven't gotten to introduce is the idea of a slope field, but I did mention that they're little baby tangents, a collection of little baby tangents. I want you guys to take these 2 pages of notes and get up to this one right here, where I'm just going to show you just one maybe 2. If I was to plug in the point 0, 0, to my differential equation, plugging in x, 0 squared is equal to 0, which means I need to, at 0, 0, make a little baby slope that's flat.
Oh, okay.
And I keep on going and making little baby slopes. I'm going to keep making little baby slopes as you guys go ahead and leave tonight. What are you doing? I'm taking notes through this example. Sound good?
Finishing my packet. Oh, but you're good.
Copy my name in the chat, yeah?
Yes.
Bye, everybody.
See you, Misty.
I'll just put it over just this. I'm going to put it over here on the tray, or on the board. Hey, Luke.
对了，上次的那个禁忌那个电影，它那个纸没有人写电影电影。
有人写了吗？这个？
一般人写I can't. And every move I make, I sort of, it's like my legs are gonna give up on me. I'll be watching you. This is so uncomfortable.